Hello, my dear students. Welcome to my channel SMK Creativity. In this video, we discuss about Ohm's law and its limitations. Here, the statement of Ohm's law is like this. The current in a metallic conductor is proportional to the potential difference applied across its ends provided the temperature and other physical conditions of the conductor are kept constant. The mathematical form of the Ohm's law is I is directly proportional to V. Therefore, I is equal to V by R, where I is the current in conductor, R is the resistance of the conductor, and V is the potential difference applied across the conductor. Then, limitations of Ohm's law. It is not applicable for semiconductors like diode, triodes. It is not applicable for metallic conductors at very low and very high temperature. It is not applicable for superconductors and vacuum tubes. Here, ohmic devices. What do you mean by ohmic devices? These are the devices which obey Ohm's law. Examples for ohmic devices are voltmeter, ammeter, and metallic conductor, etc. Non-ohmic devices. Here, these are the devices which do not obey Ohm's law. Examples: semiconductors, triodes, and diodes, etc. Here, potential difference and current versus current graphs are like this. VI graph for ohmic devices is like this. V along x-axis and I along y-axis, then the straight line for the ohmic devices. Then VI graph for non-ohmic devices such as PN junction diode is like this. Here, this is for forward bias and this is for reverse biased of PN junction diode. And then VI graph for gallium arsenide LED is given by like this. Here next, the definition of resistance. Here, resistance is the opposition offered by the conductor for the flow of current passing through it. Factors on which the resistance of conductor depends. First one, the resistance of conductor is directly proportional to its length. Second one is resistance of a conductor is inversely proportional to its area of cross section. Here, definition of resistivity of the material. It is given by resistivity of the material is defined as the amount of opposition offered by the conductor to the flow of current of unit area of cross section and unit length. It means here R is equal to rho into L by A. It means R is directly proportional to L, R is inversely proportional to A, then by removing proportionality constant, we write R is equal to rho into L by A. Our rho is equal to, it means resistivity is equal to R into A divided by L. Here, R be the resistance of a conductor, A be the area of the cross section, and L be the length of the conductor, and rho be the resistivity of the conductor. Here, next we discuss about temperature dependence of resistivity. Here, the graph of resistivity and temperature for nichrome, it is given by like this. It means here in this figure. Okay. Next, graph of resistivity and temperature for copper. This is given by like this. Temperature along x-axis and resistivity taken as along y-axis, and the curve is like this. Next, graph of resistivity and temperature for semiconductors is given by like this. Here the curve is like this. Along x-axis temperature and along y-axis resistivity, and the curve is like this. Here, in the next class, we discuss about the Gauss's law in magnetism and also in electrostatics. Thanks for watching.